This right here is a golden neural network made with Blender. Let's learn how a neural network learns. We are going to go easy there with the XOR operations where two different inputs produce a high output. A neural network usually has these three layers, and these values are randomly initialized, where these light green values represents weights. Meanwhile, these blue values represents the biases. The input layer simply sends the inputs to the succeeding layers. The same case wherever it is. When those inputs arrive at a particular neuron, there happens a magic of taking activation. This is just to add a non-linearity. Weights are multiplied by the inputs and added with the bias. Same case wherever it is. Those values are sent to the last neuron where the same thing happens. It also applies the sigmoid activation to those values with weights multiplied and the bias added. Now what we predicted is 0.7222, but the expected is 1. We calculate the distance between what is expected and what is predicted, that is the loss. In order to get the correct output, we have to adjust through the so-called backpropagation. We are in the important part right now. What we do is a partial derivative of something with respect to something. We calculate the derivative of loss with respect to a particular weight in a particular neuron. And this is the step repeated to every neuron in the neural network. And remember, we are yet to update those weights. Using this equation, we can calculate the weight to be updated and the biases also. Now again the neural network is forward propagated and different outputs will be absorbed. With more passes, the output will approximately what is expected.